Okay, well, it's great for me to be back in Reno. It's been a number of years since I've been in the regional show here. And I love to come here. It's a great group. We had a bunch of successes, kind of showed on the slide, selling 700 here, which kept me away for a while. But now we have multiple additional bands and more frequencies generally coming available. So that's the nature of the discussion today. Select Spectrum, we're in really broadband and narrowband business. We have a whole side of our business that works with carriers, wireless internet service providers, that kind of thing. That's where I came from originally. And then I've been working on the utility side, which until recently, for us anyway, has been a narrowband business. And now it's evolving to be substantially a broadband business as well. So quite a bit of experience. It's a team of 7 of us all together. And we live, eat, and breathe Spectrum. I think in terms of different alternatives here, I should say this is a focus on today 4G, 5G spectrum, right? So historically, we've been more in the narrowband business, 220 megahertz, 450, 700, as we mentioned, other bands along these lines, typically 1 megahertz bandwidth or less, right? So now with broadband, and many of these applications are suitable for those narrowband frequencies. They're typically not 3GPP standards, although there's some change in that direction I'll be talking about. So it's in what I call industrial radio. Some people call them proprietary systems, but they are designed specifically for your business. And then now with the interest in expanding, and we've seen now I guess 5 utilities make a commitment to LTE on licensed spectrum, and others to acquire spectrum, but maybe not announce their full plans yet. So there's an expanding array of applications, right down to transfer trip and some of these things that require high bandwidth and low latency. So that's good news. I'm not going to focus on the applications. I think there's lots of folks out there on the floor. I encourage you to talk to them about how broadband can enable some of these applications. And if you have a comment to make here, I'm glad to do that later. So in looking at broadband, most of the frequencies that are of interest are subject to or governed by, of course, FCC rules, but also 3GPP rules. So 3GPP is the global commercial wireless standards organization for cellular. Most people would call it cellular. We're currently, fully mature in the 4G standard, and at least the carriers are actively deploying 5G equipment as well. So as you think about whether you want to acquire spectrum, one question to ask is this just the next 10 years or so that I want this working, which is kind of the 4G lifespan at this point, or do we want to? You mentioned no longer supporting 3G. Right, so about every 10 years we have a new cycle. 5G is already here. In 10 years, your LTE modem, may not work, and you may need to upgrade to 5G capability. The good news is the organization does envision that you should certainly do the due diligence to kind of have a feeling for what your potential suppliers are going to do as these standards evolve. Obviously, it's not possible to completely predict the future, but thousands of suppliers, massive numbers of chip volumes in the billions with a B, which is going to drive costs down. So that creates additional opportunities and to suit new applications that you may not have considered before. All right, I'm going to talk about 6 spectrum bands today, I hope. 5 are on the screen. And one I found about, by the way, I encourage you to participate in UTC committees, because last week on the Spectrum Subcommittee, I discovered there's another band which is being offered to, at least rumors are that it's being offered into the utility industry. So if there's time, we'll talk about that one. And in this case, probably members in the audience know a lot more about it than I do. So maybe we'll ask for some audience contributions. But each of these are bands that are available in lots of places. I think only one of them on a license basis, maybe if you count CBRS and GAA, is available in all places. across the country, and they have different attributes. So the goal of this is to kind of go through and give you an overview that says what are pluses and minuses in each of these bands, which one should you be looking at, and kind of take it from there. Does that make sense? Okay, great. By the way, I feel about spectrum kind of the way Ron felt yesterday about poles. So if I get a little over enthusiastic, you'll understand. All right, so 600 megahertz substantially held by T-Mobile, right, is the major holder of these licenses. This was kind of an interesting auction, and because, frankly, the auction didn't go well from the FCC's perspective. T-Mobile was a very active participant, Verizon was a non-participant, AT&T was kind of in and backed out. And so Dish was in, and Dish seems to be in kind of every auction. So as a result, in rural areas, and even some urban areas, by spectrum standards, these were not tremendously expensive licenses. So in theory, and well, in practice, you can find investors who bought spectrum and could make a nice return by selling it to you at a price that is below what some of the spectrum is going for in the market today. Now, being investors, that hasn't actually worked out so well, right? So a lot of them are holding out for the big bucks that they can get from T-Mobile or Comcast or something like that. But at least in theory, this is here. And there's been a trial that's done by New York Power Authority on a lease spectrum basis with this spectrum thing, and I think they were pretty happy with the results. You can certainly look at those results. So. Excellent propagation, right? In terms of broadband, this is effectively as low as you can currently go in the US. 5+5, so quite a bit of capacity. In the spectrum world, we buy by the megahertz pop, sort of the gallons equivalent to gasoline. So 10 megahertz means you're going to get, for every person who lives in the area, that's 10 megahertz pops. The price may start to get up there quite a bit. Lots of consumer equipment, the whole T-Mobile, whatever can go on the T-Mobile network is available, chips. And while you may not be interested in that consumer equipment, those chips and the modules that chips go into can be repurposed and go into lots and lots of different devices that are relevant. There are narrowband solutions as well. So the message overall on 600 is, I think, good news is really good spectrum, if you can get it, is available. By the way, it exists everywhere, right? But T-Mobile's not partying with it, and Comcast is not partying with it in the major cities. So, and Dish has some too. The practical chance of getting that out of their hands is pretty low. But if an investor has it, and there are investors who acquire maybe 30%, something like that of the total geography, there's a chance at least. And we know the folks, we don't represent any of the kind of license holders, but we can at least talk to who you might want to see in this area. All right, 700, this has been my favorite band for most of the last decade. And some of you also know John Kozlowski at Access Spectrum. So my client, Beach Point Capital, holds these licenses. They've sold to Portland General Electric and Puget Sound Energy and California High Speed Rail and Avista and Northwestern Energy. So and other chunks in other parts of the country have been sold as well. The map that Mohan put up is current, right? So about 2/3 of the geography is still available. I would say mostly Middle East as opposed to West. Lots of different suppliers make equipment, very high power levels. It is 1 + 1 megahertz. So that is, not enough to do broadband. But what happened not quite a year ago, after quite a bit of effort on our part, we had deployed a pre-standard LTE NB IoT standard. So long-term evolution is the 4G standard, NB, narrowband, IoT, Internet of Things, right? So this is designed to do low-speed service to hundreds of thousands, maybe even millions of devices in an area that don't talk too much, right? Not lots of communication. Obviously, you don't have a lot of capacity on total of 2 megahertz, but the standard is intended, you could do smart street lights, any kind of temperature monitoring, atmospheric monitoring, gunshot monitoring. I think you can do meters if there's intelligence in the meter. Certainly gas and water is feasible. Nobody's done it yet with electric, but we hope to see some demonstrations of that coming up very soon, like maybe at Distributech. So it's pretty interesting. And so you take this standard, which was, or this spectrum, which was developed for industrial radio, and doing a fan type solution with relatively high speed, relatively low latency, industrial grade radio systems, but these are not cheap, right? If you wanted to go to pull tops or line fault sensors, this could do it, and it could do it at a very economical cost per endpoint. So interesting even for those who have the spectrum. Certainly I'm going to encourage Portland General Electric to take a look at this, and others who have it, is this an addition? It would require splitting out a chunk of that precious 1+1 megahertz of spectrum to do NB-IoT, and this does not have the full 5G capability. All right, so 900 megahertz, credit to Anterix. Some of my former colleagues over there have done a super job in terms of promoting broadband. This has been tried before with little success, to be frank, with some of the prior spectrum bands. They've done a super job in promoting this spectrum to the utility industry. They've gone to the FCC. They've gotten, this is still narrowband sliced up in 90+% of the country, right? So it still has to be converted, but they've got an FCC order and there's a process. And my understanding is, at least in areas where they hope they have a customer coming, they're working through the conversion. So far, I think it's 86, 88 counties have the broadband license. There's 3,000 counties in the US, so there's ways to go. But the path is there, the interest is there, the ecosystem is there. This is Band 8, but it's Band 8 US. So when you go to check the equipment, make sure the duplex spacing in the US matches, for that particular type of equipment, that they can do US duplex spacing as opposed to the global standard. I think those are the key. It's adjacent to LMR. So if you're planning to continue to operate your LMR system, or there's another LMR system in the area, just be aware that may require at least analysis before you go. Anything you want to add or correct here, or you wait till later, whatever you want. Okay.
Go for it.
All right. My new favorite is band 54. So this is 1670 to 1675 megahertz. It's 4G LTE approved as of December. So this approval is brand new. They've applied actually for 5G standardization. That's an official work item at 3GPP. It's heretofore the minimum channel width for 5G spectrum has been 5 megahertz. The idea is this is ultra fast broadband. Takes advantage of that wider bandwidth, allows modulation techniques that are not available in narrower bandwidth. I understand there's a work item at 3GPP to say, hey, we should be able to do 5G in 3 megahertz, and that's going forward, and we'll see how that comes out. This also has a work item. It's 4G approved, and there's a work item that we think will be done by the end of the year for 5G approval as well. So that should give you, 20-year kind of lookout once that standard is approved and the equipment is available. This is your propagation in low mid-band. Carriers would consider it their preferred, by the way, right? Because they're trying to build for lots and lots of capacity. And what, long range also means the potential for self-interference. So if you want to do super high capacity networks, this is kind of an ideal low mid-band situation. In the utility space, range is very, very important. We understand the economics of that, and I'll deal with that a little bit later. But certainly, this is in an interesting spot. I think a good spot in the overall sort of propagation versus capacity range. And you'll see there the total fixed output power, uplink and downlink, is 2,000 watts, EIRP. So to some extent, you have the ability in a fixed site to compensate for propagation, differences compared to the lower band by cranking up the transmit power. Right? Where, there's balance that has to be done there. Takes equipment that can handle that, but that's an interesting aspect of this. This is also licensed for mobile. The mobile uplink is, I think, just 3 watts, 4, sorry, for the mobile station. So, pretty interesting spectrum. T is available everywhere throughout the U.S. and Puerto Rico and Alaska and so forth, Hawaii today, right? So no clearing, ready to go. The downside of this is because it's just had approval from 3GPP, the list of suppliers is small. I think it's going to grow fast. We've got some success from other entities that have come out. And to me, I would rather be dealing with the equipment issues than some of the other challenges that are out there for other spectrum bands. Questions on that one? All right. So CBRS, I think this has been discussed more in general. This has been out there for a few years. This is licensed spectrum, kind of, right? So the government has the first call. There's some Earth stations that have priority, as well as the Navy. It's a bigger issue along the coast, or if you happen to be in one of those Earth station exclusion areas, because it's still used for certain satellite spectrum. If you're not in any of those areas, it's pretty much not going to have government issues. There's a GAA tier, so you can try this out. General Authorized Access, I think, is what that stands for. So you go to the Spectrum Availability System, the SAS, which is run by Google, or Associated, I apologize, Federated, I apologize. Yeah, we've been mad at me. Federated Wireless has a SAS. You get a registration. They keep track of who's using the spectrum where. So it's a way to drive more and more use into the spectrum. And we're active in this band. We're excited to offer, I think, 500 PALs across the country. So if you're interested in this band, the PAL, by the way, is this intermediate tier. So you have a license. If you have priority. If you're not using, then the SAS will make it available for others. You have to check that the SAS, although you have a license, the SAS tells you exactly which 10 megahertz slot you use. So it's attempting to use the kind of intelligence that's available in computer systems these days to more fully use the spectrum. The spectrum should be less expensive. I think so far it has been less expensive on a per megahertz pop basis than other bands, but it doesn't necessarily mean it's been cheap. It depends on the area. In the auction, some areas were highly demanded, and some utilities paid high numbers for this spectrum, and others were much less so. So, that overall description. This is a very interesting area, and I would say if you're trying to serve a substation, if you're trying to serve a small transmission point, this is a place where you can create a lot of capacity, relatively low cost. The power is low, the propagation is fair, right? So it's going to fit a smaller area. If you're trying to provide broad coverage, I think that's rather difficult in this band. All right, I tried to do my overall assessment. I'm sure others would have different views of this. The categories I've talked about: standardization. Without 3GPP standards, you're not doing 4G, 5G. You're doing, you may have a system, but you're going to be dependent on a particular supplier. Propagation, better to the left, not as good to the right. I think there's an advantage to at least 5 megahertz. Now we're still selling 700 1+1. It's going to be NB-IoT only, right? So it doesn't have all the capabilities. The throughput, you'll see, tends to be better at the higher end of the frequency range. In building penetration, I guess that's a similar to propagation. And then, in the end, is it available where you need it? So 600 megahertz, really good spectrum. Is it available? Have to see. And I would say for all of these, ask the multiple questions. Who's the neighbors? When will it be available? That kind of thing are important to know.
Hey, Bob.
Yes, sir.
Quick follow-up question. We've always believed in this spectrum wedding cake. You need a good foundation, and then there's certain use.
That one?
Yeah. But recently, I've heard some things about CBRS that concern me a little bit for some of the utility use cases. And maybe, can you confirm this? My understanding is when you're a CBRS, and I don't know exactly what the terminology is, but basically your station, not the endpoint, but the other collector type thing, when it goes out of service, that it has to be re-registered before it can come back online, and that's causing some delays, which would concern me for some utility applications. Can you explain that a little better?
So I am not the CBRS expert at Select Spectrum. That's a guy named Andreas Bitsarakis, and he could take you through this in great detail. Let me try to find that out. It sounds right to me, right? As my understanding is, there's essentially a heartbeat kind of thing that's going on there, and if the SAS loses connection, and obviously that's going to happen sometimes, even if you have redundancy, right? That's going to happen sometimes. There's a process for reestablishing, but I don't know the details of that situation. I will say we represent CBRS paddle holders. We recommend CBRS spectrum, but under again the proviso of look at all of the issues, right? That's really the overall perspective. Let me just hit this one quickly. So lots of vendors, right? And if you make equipment for 4G, 5G private networks and you're not on this thing, I'll buy you a beer this evening or come over and let me know what we can do to get you on this slide. So anybody want to announce, by the way, that they have a 4G, 5G product that's not on here? Not yet, okay. Do it in private, maybe. So we're doing okay on time. So the layer cake concept, I call it duet, by the way, so dual unified efficient transmission. T-Mobile talks about a 3-layer cake. So the lowest layer, typically below 1 megahertz for broadband coverage. The middle layer, typically mid-band. So to me, mid-band is 1.1 megahertz. I'm sorry, gigahertz. Typically below 1 gigahertz, and mid-band is 1 gigahertz up to 4, maybe 6 these days. Gigahertz at 6, 5 or 6, according to Mohan, is where you would build your capacity layer. So a recommendation that we are suggesting is to, as you look at your plan, think about your first implementation being either capacity or coverage. Put in a layer of the cake. Doesn't necessarily have to be the lower layer. Could be the mid layer. There's a logic to getting your coverage first. So we would say 700 is a good idea. I bet these guys would say 900 is a good idea. And then think about capacity at a mid-band level. Now, you can also do both, right? It's worth the network design. It's worth taking. So do both means pick a license that will give you both the coverage and capacity you need. I think band 54 fits very well, right? You don't have to do the layer cake. But this is the way carrier networks have evolved. They got into it, by the way, because initially the two cellular carriers, the Bell company and the other company, had a 50 megahertz spectrum. And then later on, the 1.9 gigahertz PCS spectrum came along, so new carriers had this. And they all ended up evolving to both layers of that cake. And now they've all acquired the super high, 30 gigahertz-ish spectrum. We have that too. It's probably not relevant for this group. Yes, sir.
I'm new to this stuff. Can you talk to the spectral efficiency of the products and convert the throughput?
So people will say differently, and you should get a better engineer than me to answer this question. But in my view, generally the spectral efficiency bits per hertz doesn't vary whether you're at below 1 gig or above 1 gig. On average, in a given area, 2 bits per hertz is kind of typical. So in 5 megahertz, you could get 10 megabits. Obviously, reusing that in every cell, that's a typical number. Is that helpful?
I can handle that math, thank you.
Yeah, so there are some who say you go higher frequencies, you get more, and I'll bet I get corrected after this, but that's the way I take it in general. You want to offer a comment on that one?
I think. Hello. Yeah, I think it's pretty good. You can also include the technology there as well. As the more sophisticated technologies, they improve the spectral efficiency of the data that you're carrying through, and the underlying RF environment is also a consideration.
So 5G, one of the intents is to get more bits per hertz, right?
Yes.
Okay, so maybe I answer that question when I understand 5G better than I do today. All right, so why would you do duet? I covered some of this. Broad coverage. By the way, on NB, since it's intended to be oriented to broad coverage and maybe not necessarily the best antennas, and they're willing to sacrifice throughput at the same frequency, 25 dB better link budget than existing technologies or typical technologies. So that's a lot, right? You can save money by the broader coverage and then still benefit from the global ecosystem of lots and lots of suppliers have the capability to deliver the capacity where you need it. Here's an example that we did. This is kind of the Coke bottle equivalent, right? So this is not a cell plan quality model. But we said, okay, on average, what kind of coverage are you going to get on 700? And 25 miles is a reasonable distance, even on line of sight, depending on the throughput. And then if you wanted to add in the 1670, 1675, the band 54, much shorter capacity, much shorter range, but still significant range, right? That's the whole state, and you're getting significant coverage with that spectrum at much higher capacity. So could fit if you have areas where you need broadband and areas where you just need coverage. I'll say one last thing because we got 2 minutes. What will drive the equipment availability for all these bands is the ability for us to communicate what the industry needs. And in fact, the Spectrum Subcommittee has started a survey that kind of says, what would you like to do? Because the people, Qualcomm and Telit and U-Blox and Sierra Wireless, they don't really understand this industry very well, right? They understand the cellular industry. They want to make money, but there's 3,000 utilities, and there isn't an integrated way to say, hey, here's what we're looking for. So when that survey comes around, please fill it in and get it back to the Spectrum Subcommittee, because the idea is to take that and say, hey, we had 20 utilities out of the 3,000, fill this out, and here's what they said they're looking for. And if that's the case, then we need you to build chips and modules to do that. Now, obviously, I want them to build chips and modules that work with all the bands that my clients are, that my clients hold. But in general, it'll benefit this group to make the suppliers. Once Qualcomm and Telit produce the module, it can go in lots of stuff from lots of different suppliers that you use. And so you'll have choice and availability, and you'll be able to build better systems. So take the 30 minutes it takes. Dewey did it, by the way, and filled it out. Take that 30 minutes and fill out the survey. Any other questions, last comments, corrections?